Welcome, developers and security professionals. Today, we're diving into a critical web vulnerability, XXE exploitation. XXE, or XML external entity exploitation, occurs when an XML parser processes XML input containing a reference to an external entity due to weak configuration. This vulnerability can lead to severe consequences, including data disclosure, denial of service, server-side request forgery, and even remote code execution.
At its core, XML, or Extensible Markup Language, is a data storage and transport language that uses tags and attributes to structure information.
Within XML documents, entities act as storage units for data. These can be internal or external, with XXE vulnerabilities specifically targeting external entities. An XXE attack unfolds when an XML parser processes a reference to an external entity containing a uniform resource identifier, or URI. If this URI is malicious, the weakly configured parser might then disclose confidential information from the server. The attack typically begins with an application receiving XML input from a user or another system. This XML input then includes a reference to an external entity, often pointing to a URI that the attacker controls or specifies. A weakly configured XML parser then attempts to resolve this external entity by accessing the specified URI, unknowingly fetching potentially malicious content. Depending on the URI, attackers can achieve local file disclosure, accessing sensitive files like /etc/password on Linux systems. They can also perform server-side request forgery, causing the server to request internal or external resources, enabling internal system scanning. Another outcome is denial of service, where the attack consumes excessive server resources, making the application unavailable. Consider this malicious XML payload. It defines an external entity X pointing to file /////etc/password. When processed, this payload attempts to read the /etc/password file, potentially exposing user account information. In blind XXE scenarios, application responses don't directly reveal external entity values, but exploitation is still possible. Attackers can use out-of-band data exfiltration, forcing the server to send data to an attacker-controlled system. They can also exploit parsing errors to leak sensitive data, even without direct output. XXE can be exploited through various attack vectors, including malicious XML file uploads, such as docx or SVG files. SOAP requests can also be manipulated by injecting payloads into SOAP messages, targeting web services. Additionally, XInclude, a mechanism for merging XML documents, can be used to incorporate malicious external content. The most effective prevention strategy is to disable DTDs and external entities in your XML parsers.
If complete disabling isn't feasible, ensure they are specifically disabled for each parser configuration.
Always use updated XML parsers with built-in protections and implement robust input validation to sanitize user input. Consider whitelisting external entities only from trusted sources and, where possible, use simpler data formats like JSON over XML. Regularly update your XML parsers and libraries, and provide comprehensive developer training on XXE risks and secure coding practices. Finally, utilize security tools like SASD, DSD, and ISD, and deploy a web application firewall to block XXE attacks proactively. Understanding XXE mechanics and implementing these prevention techniques is crucial for mitigating risks and securing your applications.